So what are some applications of priority queues? Well, let's look at, for instance, max queues. This could be, in the unfortunate case of a disaster, for instance, and the medical personnel set up a triage system. They usually want the most hurt person to receive care. And so that would be a max priority queue if for some reason we say that having a certain level of hurt, a maximum level of hurt or a higher level of hurt is what makes you a top priority. Okay. Additionally, things like jobs, this is often used in scheduling. Priority queues are used in scheduling. Jobs that require the greatest resources. Those jobs tend to move to the front of the line so that they can utilize the resources and hopefully free them up later on for the lower priority jobs. What about min priority queues? Well, shortest job. For instance, if you're given 10 tasks and you want to get credit for completing as many as you would like to, you might want to do the shortest jobs first. So that's an example of a minimum queue. Minimum priority queues are often used in simulations in something that's called discrete event simulation, where the events are ordered by time, and obviously the earliest time those events get done, they get done first. As a result, the time queue in a discrete event simulation is an example of a minimum priority queue. In general, we can use priority queues for anything, so we're not just restricted to these examples. We can use a priority queue for anything where there's some kind of ordering established between events or between entities. As far as the STL goes, the STL does allow for implementation of priority queues, and I should say it does implement them. And you need to include the queue header file, and it does default to being a max heap or a max queue. So normally we will instantiate these with an object type, a container type, which defaults to vector, and a comparator. This comparator business is going to become pretty important for Project 7 because I'm going to ask you to implement a priority queue as a class template, okay? And one of the items that will be passed to this priority queue will be a comparator, which is how we establish what is the higher priority. So for instance, in a max queue, greater than had the highest priority, but in the min queue, less than has the highest priority. But the mechanics of the queue, as you'll recall from the examples we went over, they're the same. And really the mechanics involve moving around higher and lower priority items. And if you think about it from that perspective, then it applies to both min queues and max queues. And so we will for Project 7 write one class that can handle both min queues and max queues, and it can handle a specific object type, like a gas pump object or a ship object or something like that, right? So in the STL then, you have the ability to instantiate these, but in 3110 you will write your own. So here are some key member functions. This is pretty much what I described earlier as having the key functions for the priority queue abstract data type. I called it NQ and DQ. The STL calls it push and pop. I called it peak or top. STL calls it top to look at the largest item. And then we have the function empty, it checks if the queue is empty, and the function clear, which actually erases or clears out the priority queue. So with that, this brings us to the end of the block on heaps and priority queues. And so the things to sort of take away from here, number one is to remember that a priority queue is an abstract data type. It is not a data structure, whereas a heap is a data structure. And a heap is often used in the implementation of priority queues. We see that we can, basically there are two main things we do with priority queues. We enqueue items into them and then bubble those items to the right level, or heap them to the right level, or we remove the highest priority item. We've gone over those functions. We've done examples, and now remains for you to implement this during project 7.